Welcome to your first video for your class on geometry for middle grade math teachers. In this video, we're going to work together to explore some special issues related to area and perimeter. Before watching this video, we wanted to remind you that you should have done three things. The first thing concerns a sheet entitled Pre-Reflection on Area and Perimeter. This is a sheet containing questions about your personal experiences related to your learning or teaching of area and perimeter. Please be sure that you've responded to those questions before watching this video. The next thing we asked you to do is to participate in a discussion board with your classmates in which you shared your written experiences with them, you responded to their insights, and they in turn responded to yours. And hopefully you got some interesting feedback from engaging in this discussion. And the last thing we wanted to remind you of is that this video has an interactive component, and for this video, that's going to mean that you should be prepared to actually do the exercise that we are presenting as we do it in the video. So be sure you have your paper square, a pair of scissors, and a pen or pencil and something to write on. In your pre-reflection, we asked you to think about your experiences learning and teaching area and perimeter, and we also asked you to think about some of the challenges in teaching these topics to kids. From our own experiences, even into college-level classes, we continue to see students confuse formulas for area and perimeter, essentially invoking a formula for area when perimeter is solicited, or the other way around. We also did a little bit of research into the topic of student struggles and misconceptions with area and perimeter. This research shows that students will also confuse the meanings of area and perimeter. So if a student is asked to find the perimeter of the pentomino shown, they might count up the squares and say that the perimeter is 5. And the research also shows that if a figure is partitioned and the resulting shapes rearranged, students will struggle to understand the impact of these reconfigurations on the area and perimeter of resulting shapes. In this video, we're going to focus on exploring this last misconception with your square and your scissors. We're going to start out with your paper square and assume that it has a side length of s. So for this square, that means that we can obtain its area by multiplying the length and width together to get s times s, or s squared, square units. The perimeter of the square can be obtained by adding s plus s plus s plus s to give 4s units. We're going to be cutting the square in half in a special way, and then we're going to rearrange the resulting shapes to get a new shape. And for that new shape, we're going to ask, what's the area of the new shape, and what's the perimeter of the new shape? And as we repeat this exercise, we'll be able to investigate how the area and perimeter of the newly arranged cutouts compared to the area and perimeter of our original square. So let's get started. Take your square, and we ask you to cut it in half by finding the halfway point on one of the sides as illustrated here. Think for a minute about how you can figure out where half of that side length is, because we didn't include a ruler in our list of tools. One thing you can do is to fold the paper in half, taking one side and folding it onto its opposite side, and the resulting crease should give you the halfway line. And now you can use your scissors to cut the square in half, and you're going to take your two resulting rectangles and arrange them alongside each other as illustrated. And it's as if there's an imaginary seam joining them together. You can see that you're making a new longer rectangle with this rearrangement, and now you can ask yourself, what's the area of this new rectangle, and what's the perimeter of this new rectangle? And as you ask yourself these questions, also reflect on how you justify your responses. So when you figure out, I think the new area will be such and such, make some notes about how you reached your response. And when you figure out, I think the new perimeter will be such and such, ask yourself how you reached that answer as well. So you can pause the video now to take some time to work on what we presented. Okay, let's take a look at the area of the new shape compared to the area of the original square. So, did you obtain that the areas are the same? And if you did, how did you justify that? One way to think about this is to see that when you cut the square in half and rearrange it into the rectangle, all you've done is to take the original area of the square, divide it into two pieces, and rearrange it into the area of the two smaller rectangles. So this is a good argument for showing that the areas do in fact stay the same. Now let's take a look at the perimeter. So how does the perimeter of the rectangle compare to the perimeter of the square? Here's one way to think about this question. Let's match up some segments on the square to some segments on the new rectangle. For example, that top segment can be matched up with this one because they have the same lengths. These two segments have the same lengths. These two segments have the same lengths. And finally, these two segments also have the same length. So it's definitely the case that the rectangle's perimeter is bigger than the square's perimeter. But now here's another question that emerges. Can you tell how much bigger it is? If we look at these two segments, we're reminded that each of these is half the length of the original square's side length. So adding them together should give us a side length of s, and that's going to give us a new perimeter of 5s. If you need to now, pause the video again, think about how your answers compare to our answers, and how your justifications compare to our justifications. So now what we'd like you to do is to repeat this process at least once. Take these two rectangles, fold them in half lengthwise, cut them along the crease that you create, and arrange them again lengthwise, as illustrated. And this time, we're going to leave it to you to determine the area of this new, much longer and much skinnier rectangle, and to determine its perimeter as well. We're coming to the end of our video, and we wanted to leave you with these closing thoughts. If you're thinking of using this exercise or an exercise of this kind in a class with your students, we encourage you to think about the kinds of issues that will influence the approaches that you take. Certainly working with students who have background knowledge in variables will be different than working with students who don't have this knowledge. You could make the exercise more accessible to the latter group by assigning a numerical length to the side of the square. You should also consider what kinds of questions you might ask to push your students' thinking along. If you continue this process of cutting the rectangles along their widths and arranging them lengthwise, which shape are these rectangles going to be approaching? What's the area of the shape that's being approached? And what's the perimeter of the shape that's being approached? And how do all of these changes compare to our original square? These are all fun and important questions for you to think about, and we're going to be using these as fodder for our next online meeting.